planet Earth is home to millions of different life forms and most advanced species in our galaxy. Earth's unique atmosphere comprises of various gases, in which oxygen plays a very important role in supporting life on this hospitable planet. Throughout Earth's existence of 4.5 billion years, oxygen concentration has been changing.
The history of oxygen gas.
To understand oxygen's history, we have to take a walk back in time. As we go back in time, notice how oxygen levels fluctuate. Oh, the Jurassic period. No, not here. We have to go even further. The Devonian. Nope, we have to go even further when the first plants even appeared. Let's just skip through the boring billion. Nothing interesting happened in this period. Aha! Finally! Here we are. So the story of oxygen begins within the Proterozoic eon, when oxygen levels were approximately 1%, and when Earth was a green planet.
In the Proterozoic eon, an abundance of methane in the atmosphere and oceans, along with the green rust from dissolved iron in the oceans, gave Earth its distinct green color. However, oxygen levels were poor. But how did the oxygen levels increase?
The story of cyanobacteria.
Cyanobacteria is a microorganism that uses carbon dioxide, water, and sunlight to produce energy, and excretes oxygen in the process. Oh, that's disgusting. Oxygen gas, however, is a strong oxidant and can kill anaerobic organisms not adapted to it. So simultaneously, as cyanobacteria increased, oxygen concentrations also increased on Earth. Well, the poor folks then drowned in their own waste, almost going extinct.
Remarkably, after the rise of oxygen for almost 200 million years, the competing need for oxygen in the oceans to oxidize iron did not allow oxygen to move into the atmosphere. Only when the oceans became saturated with oxygen, it leveled up to the atmosphere. However, oxygen levels were not sufficient, as it was taken up to oxidize minerals on Earth and was destroyed by the presence of methane in the atmosphere. Soon, the increase in oxygen concentrations due to a combination of volcanism and rise of continents led to massive oxygen accumulation in the atmosphere. And as this large-scale oxygenation happened, it turned the Earth into a red planet. The sedimentary red beds and banded iron formations evidently indicate this massive rise of oxygen.
What happened next?
Oxygen conquered over methane and carbon dioxide in the atmosphere that previously kept it warm. And further extension of oxygen into the stratosphere formed the ozone layer that shields us from the ultraviolet rays of the sun, and perhaps further triggering the ice ages.
The subsequent glaciation, or we could say the Huronian glaciation, probably resulted in another mass extinction. But how do we know about this and the preceding events?
The science behind it.
Well, scientists have a fun way to date the historical events on Earth, and as such, they use fossilized records and isotope data. Therefore, ice core data explain much of the recent atmospheric concentrations about hundreds of thousands of years ago. Oh, that's freezing down there in Antarctica. Well, whereas for events like the Great Oxygenation, more deeper and rigorous data of sedimentary rocks dated back to billions of years can be used together with hypotheses of banded iron formations that provide evidence of this event taking place back in time.
Emergence of cyanobacteria before the Great Oxygenation event can be linked to the initiation of the Great Oxygenation event. However, presence of oxygen even before the cyanobacteria emerged is somewhat controversial, as several other hypotheses do challenge this theory, such as plate tectonic activity and plant photosynthesis. But it is important to note that the Great Oxygenation event was not a short period, and it took almost 4 million years for oxygen to accumulate and stabilize at the current levels on our planet.
Well, all that information is a little hard to absorb now. So let's just take a deep breath to try and absorb all this amazing information. Or better still, let's just take a deep breath to absorb that pleasant oxygen. Thanks for listening, folks. Hope you enjoyed our video.